Today, we will discuss a 3-point test cross analysis in a maze involving 3 traits. First one is a booster B, a dominant gen that intensifies plant color. Number 2 is ligulous leaf LG, a mutation that causes leaf to lack ligulous. Number 3 is tassel seed TS, a mutation where seed develop on the tassel. These traits are controlled by gen located on chromosome. When gens are located close together on the same chromosome, they tend to be inherited together. This phenomenon is called genetic linkage. The objective of this question is to determine the gen order, estimate the distance between gens, calculate interference, and determine the expected number of a double crossover.
For the question A, first, I identify the parental classes by selecting the two phenotypes with the highest frequencies, which are ligulous with 57 offspring and also tassel seed with 57 offspring. Next, I identify the double crossover classes, which are the least frequent phenotypes. These are ligulous with 7 offspring and booster tassel seed with 8 offspring. To determine the gene order, I compare the parental classes with the double crossover classes. When I compare the booster, ligulous with ligulous, only the booster gene change. Similarly, when I compare tassel seed with booster tassel seed, only the booster gene change. In a 3-point test cross, the gene that change between the parental and double crossover classes is the middle gene. The gene order is ligulous, booster, and tassel seed. The parental chromosome arrangement is BLG plus over plus plus TS. The genes are originally linked as BLG plus over plus plus TS with the gene order LGBTS. In summary, by comparing the parental and double crossover classes, we found that booster is the middle gene, giving the gene order LGBTS.
For question B, to estimate the distance between the gene, we identify the recombinant class for each gen interval. For the distance between B and LG, the recombinant classes are what type is 20, booster ligulous tassel seed is 21, ligulous is 7, and the booster tassel seed is 8. Distance between B and LG is 20 plus 21 plus 7 plus 8 over 222 multiplied by 100, and we get the answer is 56 over 225 multiplied by 100, and the last answer is we get 25.2 centimorgan. For the distance between LG and the TS, the recombinant that we get is a classes are booster is 31, ligulous tassel seed is 21, and ligulous 7, and the last is a booster tassel seed is 8. So the distance between LG and TS is we have to 31 plus 21 plus 7 plus 8 over 222 multiplied by 100, and we get the answer is 67. So 67 is over 222 multiplied by 100, and we get the last answer is 30 plus 30.2 centimorgans. Hence, the genetic map is B to LG equals 25.2 centimorgan and LG to TS equals 30.2 centimorgan.
Hi, I will be explained for question C. First, we find the observed DCO frequency by dividing our smallest data groups, 7 plus 8 by the total offspring of 222. This calculation of 15 divided by 222 gives us approximately 0.0676 or 6.76%. Second, we need to calculate the expected DCO frequency by multiplying the distance of both gen regions, which is 0.252 times 0.302. This gives us 0.0761 or 7.61%. Next, we calculate the coefficient of coincidence, or letter C, by dividing our observed frequency by the expected frequency, that is 0.0676 divided by 0.0761, which equals 0.888. Finally, using the interference formula I equals 1 minus C, which is 1 minus 0.888, we get our final answer of 0.112 or 11.2%. This proves that the first crossover event physically blocked 11.2% of the expected second crossover events on the chromosome.
Untuk bilangan double crossing over DCO yang dijangkakan, kita boleh menggunakan hasil darab dan frekuensi rekabilitasi daripada kedua-dua selang gen. Daripada pengiraan sebelumnya, jarak antara gen B dan LG adalah 30.18 cm, manakala jarak antara LG dan TS ialah 25.23 cm. Oleh kerana 1 cm bersamaan dengan 1% rekabilitasi, maka expected DCO frekuensi ialah 0.3018 darab dengan 0.2523 sama dengan 0.071. Ini bersamaan dengan 7.61% daripada jumlah progeny. Jumlah keseluruhan progeny ialah 222. Jadi bilangan DCO yang dijangkakan ialah 0.0761 darab dengan 222 sama dengan 16.9, iaitu kira-kira 17 progeny. Oleh itu, berdasarkan andaian bahawa kejadian crossing over pada kedua-dua selang gen berlaku secara bebas, kini menjangkakan kira-kira 17 individu double crossover akan diperoleh.